Okay.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening, everyone.
Good evening, sir.
Good evening. Good evening. So only when we thought that we won't be meeting again. Here we are. We will be having a revision class. So nice of them to arrange this. So see, first of all, honestly, I initially felt that revision class or research, especially in the month of January or whatever, it's not required because I don't know. It depends. That some of you might require it, some of you might not. But then I thought, since I'm getting this opportunity to take a revision class, so what we can do is theory. Though we have already obviously nicely covered. So we'll take good glance of the theory. But what I have tried to do today is accumulate some good questions, the ones which we have not taken before in the class. So those are the kind of questions that we will take, and with the help of those questions, we will be able to maybe understand more about the theory and recall all the concepts that we have done. So obviously, I'll be taking revision of only two subjects, the ones that I have taught you, classical and modern. So today we are going to start classical, and I'm planning to take 3 lectures for classical and 3 for modern people. So I'm going to divide the revision of all the chapters in these 3 lectures of classical. Okay. So let's get started. And remember, it's not a doubt solving class. It's a
Excuse me, sir.
Yes, please, sir.
Excuse me, sir. Sir, I sent you a question on. I think you remember about the question. I've sent you a question personally, and that's about classical mechanics. That is a combination of rotational mechanics and
wait, listen. Honestly, as far as I understand, I probably responded to everybody's doubts, but I'm not sure. On which platform did you send?
Instagram.
Okay, don't do that. Mail me. Okay. So people, like whoever have those students who have mailed me the doubts, I have responded to them back. Okay. Or you can also like message Uncle. Like they have also given you a number. I remember last time. So you can also message them. They can also send me. But that's a long process. So mail is also cooperative and they are permitted to converse on this. But on other platforms, it's recommended not to discuss things. But okay, but yes, you mail me your questions and I will try to get to you.
सर मैंने मेल किया था आपने रिस्पांस नहीं
कर
किया
दिया कर दिया
ओके सर
हाँ देखो तुमने देखा नहीं है ठीक है अभय had also sent me some questions and I have responded to him as well हाँ but okay anyway so let's get started okay so let me just arrange this just a second now hang on okay so we are going to start with the revision of classical mechanics people let me just change the settings just a second आदत छूट गया ना settings बदलने की okay okay it should work now yes so classical mechanics people and classical mechanics, what the topics that I'm planning to cover today is first velocity and acceleration in 2D theory. After that, we will take Newton's laws of motion. Okay? Then we will take friction. We'll also take pseudo force. We'll take variable mass problems. These are my minimum target. And if time permits, then we will take some problems on work power energy too. So this is what I plan to do today. Okay? So let's get started, people. So first, let's recall velocity and acceleration in 2D and 3D. It will be a quick class, and like I said, it's not a obsolete class. It's only a revision class, people. So, but yes, while I'm teaching you something, if you have some question related to that, you can ask me immediately. Okay? And otherwise, if you have any other doubts in the topics that you have been learning, you can always mail. So that's the thing you have. Okay. So to start with, our coordinate systems, we obviously divide them, if you remember, in 2D and then in 3D. In 2D, we have got one is Cartesian, about which we are least worried because that's our favorite. Okay, X, Y, and another is polar. This is where the things get a bit more interesting, R and theta. In 3D, we have got again actually two coordinate systems. One is again Cartesian, other is again polar. Okay, in Cartesian we have got X, Y, Z. In polar, we have got 2 more. One is spherical, and another is cylindrical. So yes, in spherical coordinates, we have got R, theta, phi, and in cylindrical, rho, phi, z. So we are just gearing up people. Obviously, it's not fundamental. We are not going to go throughout the class. Okay? We're just gearing up right now. Okay. So to start with, let's directly jump on polar coordinates. Cartesian is completely fast. Okay. So for polar coordinates, people, if you remember, the position vector, like we are talking about 2D polar. Okay. We are talking about 2D polar. So the position vector R vector, it was just R vector. R vector was R vector. Nothing else because R vector was position itself. However, for example, in cylindrical, rho is not R vector. No? Rho was actually the perpendicular distance of the point from the z axis. Like if this is the z axis, if this is the disk, then the perpendicular distance that was actually rho. And if here you have the origin, then this becomes R. Okay. So R and rho are different things in cylindrical. However, in spherical coordinates, in polar coordinates, R is R. R itself is position vector. Okay? Then we can write R vector as R into R cap if you want. Then we derive velocity vector. Okay? Velocity vector has 2 components. One is the radial component, other is the angular component. VR vector and v theta vector, which we can write it as VR into R cap plus v theta into theta cap. What was our radial velocity people? R dot. Okay? What was our angular velocity? Tangential component, angular component. It has multiple names. Tangential component. Okay? Angular component. It is also popularly known as transverse component. Okay? So you can write any of this. And that was R into theta dot. Okay? Theta cap. Dot means first derivative. So when you say R dot, that was dr by dt. And when you say theta dot, that is d theta by dt. Okay. When you say d theta by dt, this is rate of change of angular displacement with respect to time. That was our angular velocity, omega. Okay. So that was VR and d theta. And then we also learned A vector, if you remember. A vector was AR into R cap plus A theta into theta cap. AR was actually R theta double dot plus 2 R dot theta dot. I'm not 100% sure if I'm writing correctly. That's wrong. So AR was R double dot minus R theta dot square. And A theta was R theta double dot. Yes, plus 2 R dot theta dot into theta cap. Okay. And in this, when you say theta double dot, people, pardon?
R cap.
Absolutely. That's absolutely R cap. No wonder. Okay. So when you say theta double dot, that's actually second derivative of angular displacement with respect to time. So that's angular acceleration. Because I can write this as d by dt of d theta by dt. And what is d theta by dt? D theta by dt is actually omega. D theta by dt is omega. And d omega by dt, this actually becomes alpha. Right? So we're just recalling a few things. If you want, you can quickly write things or take a snap or whatever. Because I just want to take numericals. And we're just gearing up, like I said. Otherwise, we are not going to go with this fundamental. Okay.
Yes, sir.
Okay. I think you're already here because you had a lecture before our class as well. Let's just directly take a question. Just question number 1. Here we go. Okay, so here's a question for us. The question is, if radial and transverse velocities in plane polar coordinate system are always proportional to each other, then what is the equation of path? K and A are constant, random constants. You can write C1, C2, you can write alpha 1, alpha 2, doesn't matter. These are random constants which you are allowed to create your way. Okay? So they have given us radial and transverse are proportional to each other. VR velocity, radial velocity is proportional to transverse velocity. Okay? Radial velocity is R dot. If you remove proportionality, you will have a constant. Just a minute, let's write down this. If you remove proportionality, there will be a constant, let's say constant K. You can write C1 also, doesn't matter, right? Whatever constant you want. Constant K into V theta. What is V theta? V theta is R theta dot equal. What is dr? What is R dot? dr by dt. K into R, theta dot is d theta by d. By the way, just a second. When you say equation of path, what is the meaning of that? Equation in Cartesian is relationship between y and x. For example, y square equals to 4ax, which is parabola. X square plus y square equals to r square, which is circle. So when you say equation, it means relationship between the coordinates, relationship between y coordinate, x coordinate. But here, obviously, relationship is in the polar world, plane polar coordinate. So you have to find relationship between r and the theta. Correct? So dt gets cancelled. I think you know how to find this relationship. We are supposed to integrate, right? It's variable separable. dr upon r, this is k d theta. Integrate both the sides. Integration of dr upon r, this is k integration of d theta. Okay? Give any initial values, whatever values you want to give. They have not exactly given us any constant, but okay. What is integration of dr upon r? That's log r. Okay. Wait, I think we should give some initial values now. I'm also thinking now. But we cannot give 0. They should have given some initial value actually. Okay, let's just write it this way. Integration of dr upon r, that's log r. This is here. Integration of d theta, that's theta. Let's say there is some other constant c. Because limits are not given to us, right? Have they given us initial values, final values? No. So when they don't give us initial and finals, we are supposed to write it in the form of. Now the problem is we don't have log here. Okay? It means we are supposed to take exponent on that side. It has exponent e equal. So I can write this as e raised to k theta plus c. And you know what is log of e to the base b equals to c? A is b raised to c. So log of r to the base e, k theta plus c, r will be e raised to k theta plus c. Remember, you are allowed to ask me doubts related to what we are learning. And I'm running fast because it's a revision class, but you can always tell me that, sir, please react me. No problem. Okay? So r e raised to k theta plus c. Okay, so we are very close. I can split them. E raised to k theta, e raised to c. So this becomes e raised to k theta. People, e is a constant, 2.71 or something. C is a constant. What is constant raised to constant? Another constant. Let's say c2. Right? Whatever notation you want, right? C2. So your answer r is c2 e raised to k theta. Do we have something like that? We have got r, but we need exponential. We have r is a e raised to k theta. So instead of c2, they have used a. K is k. No, these are constants. You can have constants however you want. So answer is definitely option C. I hope you understood this. Tell me, make it up. Take it.
Yes, sir. Yes, sir.
I have to check something. No problem. So let's take another question. A good question. I'm going to the next page. Here we go. 1. Where is 2? Numbers are okay. This is 2. So here's a question, people. A particle moves in a plane with velocity this such that VR is 3 by 4 v theta. The time dependence of the magnitude of the velocity is this. It is given then this. At what time this? Okay, blah blah blah. So let's take one thing at a time. First, we have a relationship between VR and v theta. Using this, just like last time, we can derive a relationship between r and theta. Just like last time. Let's do that first of all. So VR is 3 by 4 v theta. Okay, VR is dr by dt. This is 3 by 4 v theta, which is d theta by dt. dt gets cancelled. We have got dr. V theta is r dt. You can always argue on. V theta is r into theta dot. No? So r into dr by d theta by dt. You can always argue. Please tell me if I have any confusion. It's r theta. So r into theta by d. dt gets cancelled. We have got dr upon r. This is 3 by 4 d theta. Let's integrate. So integration of dr upon r. This is 3 by 4 integration of d theta. Have they given us limits this time at least? Yes, they have given us. And it is given that r is 1 and theta is 0. So when theta is 0, the value of r is 1. Let's say when the value of theta is theta, the value of r is r. Okay, so that way we'll get the relations between r and theta. Now you don't have to write constants here. Now we will not write constants because we have got limits. Okay? So integration of dr upon r, that's again log r. This is equals to 3 by 4 integration of d theta, which is theta. What is lower limit here? 1. What is upper limit here? R. What is lower limit here? 0. What is upper limit here? Theta. Upper minus lower, so that's log r minus log 1. This is 3 by 4 theta minus 0. Log r minus what is log 1? That's 0. 3 by 4 theta. So we have got log r is 3 by 4 theta people, or you can say r is e raised to 3 by 4 theta. R is e raised to 3 by 4 theta. We have got a relationship between r and theta right now. Copy this much better. Then we will see what to do. Actually, I don't know whether we will be using that or not. It's just a temptation to derive relationship because we already did. But I think it will be used because anyway they have given us addition, so it will be used.
Yes, sir.
And those, I'm not sure, most of you probably have attended our regular lectures because I'm not sure if there are admissions only for revision classes or something like that. So for questions, you are supposed to take screenshots, okay? So that you can just write those questions later. You can leave the page, half a page on the page, and write those questions later. So, next, I hope you copied this one. Let me know if you're writing and let me know if you have questions related to this. Okay. So again, what I've done is I take the exponent on that side, so r becomes e raised to 3 by 4 theta. Now let's read and cancel the thing which are already used. A particle moves in a plane with velocity. This we already know, yeah, it's time pass. So the whole first line is time pass. We already know this. VR is 3 by 4 v theta. Okay, we have already used this, but we will write it. VR is 3 by 4 v theta. So this is information that they have given us. Okay. The time dependence of the magnitude of the velocity. People, have they mentioned which velocity? Radial. Have they mentioned transverse? It means which velocity is this? Total velocity. When they don't mention magnitude of which velocity, it means they have given you magnitude of the total velocity, which is 5t. Okay, so let's now play with this. Magnitude of v is 5t. What is magnitude of v? Under root of vr square plus v theta square. This is 5t. Okay, so this is under root of what is vr people? 3 by 4 v theta. Okay, the whole square plus v theta square. This is 5t. We can square on both the sides. Okay, or square करेगा correct? नहीं करेगा because this is actually 9 v theta square upon 16 v theta square plus v theta square. This is 5t. So this is under root of 9 plus 16, which is 25. V theta square upon 16. Denominator does not have v theta square. This is second. Okay, so theta square, that's 9, 4 square, that's 16, v theta square, that's v theta square. Like this cross multiply, 9 plus 16, that's 25, v theta square by 16, this is 5t. Under root of 25 is 5, under root of v theta square is v theta, under root of 16 is 4, this is 5t. So we have a relationship between, 5, that's interesting again. So we have got v theta is 4t. What is v theta? R theta dot. This is 4t. Okay, so R, what is theta dot? D theta by dt. This is 4t. And what is r, people? E raised to 3 by 4 theta. Outstanding. So E raised to 3 by 4 theta, that's r, d theta by dt, d theta by dt. This is 4t, and I think now we can get another equation here. So, but E raised to 3 by 4 theta, d theta, this is 4d dt. Integrate both the sides. Integrate. Integration of E raised to x is E raised to x. Integration of E raised to 3 by 4 theta is E raised to 3 by 4 theta. You have to divide by the constant 3 by 4. 4 outside. Integration of t, that's t square by 2. But what about limits? Let's check the limits now. So it is given that r is 1, theta is 0, at t equals to 0. So when time is 0, theta is 0. When time is 0, theta is 0. So let's say at any time t, theta is theta. What is it that they're asking us? They're asking us at what time theta will be 4 radians. Okay, so let's substitute that now. They're asking us at what time theta will be 4 radians. Let's substitute that. There is eraser. So let's say we want to find at what time this time theta should be how much? Theta will be 4 radians, people. Okay, I hope the problem is understood. The question is understood. The solution
yes, sir. Sir, इसमें constant नहीं आएगा integration?
No, you have put the limits now.
अच्छा, okay, definitely. Okay.
Yeah, definite integration. Okay, so we have what? 4 by 3 e raised to 3 by 4 theta. 4 by 3 e raised to 3 by 4 theta. Lower limit is 0, upper limit is 4. 4 by 2 is 2 t square. Lower limit is 0, upper limit is t. Okay, so we have what? 4 by 3 upper minus lower. So e raised to 3 by 4 theta. Theta is what? 4 minus e raised to 3 by 4 into 0. Because listen, people, for a second. Mostly it happens with many students. When you substitute 0 now, you end up thinking the value will be 0. It's a human tendency. Many times that will happen. That suppose if you have cos theta, and if you're substituting the lower limit 0, cos 0, you might just end up writing 0. Have patience now. E raised to 0 is 1 here. Cos 0 is 1. Not every time I even substitute 0, answer will be 0 now. At places, it may not even be 0. So here it's not 0. Don't think it is 0. Here you have a value. Okay, take care of that. So this is 2 into upper minus lower. That's t square minus 0. So this is 4 by 3 e cube minus 1. E raised to 0 is 1 now. This is 2t square. Okay, e cube we have given us, by the way. E cube is 20. They have given us. Okay, so this is 4 by 3 into 20 minus 1. Okay, this is 2t square. So we have got 4 into 19 upon 3 into 2. This is t square. So we have a t which is under root of 2 1s are 2 2s are 2 19s are 38. 38 by 3 seconds. Answer is option B. Which page are you copying? Have you guys copied the first page? If anybody is writing the first page, let me know. First is done. Okay, copy the second. Ask me if you have any genuine questions here. Any questions? Questions are genuine. So, okay. Okay, I'm going to the next page. Let me know if you're writing. Copy this too. So my plan is to mostly take the lectures like this only. Let's take little important formula here and there, on the basis of which I feel that the question will be framed in exam. We'll take numericals related to that. And those numericals which we haven't done already in the class, so that you have more problems.
Yes, sir. Done.
Okay, sure. So now let's just also pen down the formula for like you already have the formula with you, but still the value of velocity and acceleration. In first we will learn cylindrical, and then we will learn spherical. So see, for 2D polar, the value of r vector is r into r cap. The value of v vector, which is vr into r cap plus v theta into theta cap, where vr is r dot and v theta is r theta dot, and the value of a vector is r double dot minus r theta dot square into r cap plus r theta double dot plus 2 r dot theta dot into theta cap. Okay, I had given you a shortcut trick to remember 3D cylindrical if at all you ever get confused. 3D cylindrical. It has rho, phi, and z. Here you have got r and theta. The role of r is played by rho actually. The role of theta is played by phi, and z is just a vertical height. Basically, when z becomes 0, so the whole graph, the whole cylinder becomes a circle. It's a cylindrical coordinate. No? So if cylinder does not have z axis, if cylinder's height becomes 0, what will happen? It will become a 2D circle. It's like you're compressed to the cylinder. So cylindrical coordinate converts itself into 2D polar when z becomes 0 basically. So all the formula that you have here should also be obeyed here too. So for an example, if we talk about r vector, here you have r into r cap. The role of r is played by rho. So we have rho into rho cap. Just that because you have an additional z, you have an additional term z into z cap. That's it. Next, what is velocity vector? Here you have r dot into r cap. Here you have rho dot into rho cap. Here you have r theta dot into theta cap. Here you have rho phi dot into phi cap. The role of r is played by rho. The role of theta is played by phi. And just that because you have z here, what is the derivative of z? Z dot. That's it. An additional term. Then you have acceleration vector, which is again r double dot minus r theta dot square. So rho double dot minus rho phi dot square into rho cap. Correct. Then rho theta double dot plus 2 rho dot. Sorry, I mean convert r theta into rho phi again. So this becomes rho phi double dot plus 2 rho dot phi dot. Okay, into phi cap. And just that you have got z dot. What is the derivative of z dot, people? It's z double dot z cap. This is how you remember cylindrical. I personally have not exactly by heart cylindrical. I take a minute, I recall 2D polar, and I just write cylindrical with a good terminology. Okay. But yes, in spherical we don't have as such great tricks, and I don't think they will probably ask you a direct question on spherical. It will be very harsh of them to ask a direct question on spherical because the formula becomes too complicated there. But still, we will pen down the formula because I want to take a question on that. So even I have not taken these formula obviously. Just a second. If I don't want to do a mistake in writing the formula, so let's pen down. Okay. So what happens in spherical? In spherical coordinates, we have got r, theta, and phi. Okay. So r vector, that's still r into r cap. That thing doesn't change. So that doesn't change. But yes, v vector, it has got components. So to start with, the first component is fine, r dot into r cap, that is still the same. The second component is also fine, r theta dot into theta cap, that's still the same. It's only the third component that now creates first. We have got a third component here, which is r sine theta into phi dot into phi cap. This is an additional component. But the thing is, after differentiating this, acceleration becomes very complicated. Velocity is still fine. Velocity is still easy to remember now. R dot into r cap, that's 2D polar. R theta dot into theta cap, that's also 2D polar. Just that this is an additional term. R sine theta phi dot into phi cap. I had this one. If they ask you acceleration, that will be too fast. But okay, acceleration, which is the first few terms will be same. What are the first term, people? R double dot minus r theta dot square. That has to be same. That cannot change. Why? Tell me one thing. Again, a sphere. If you remove azimuth, like if you say that there is no azimuthal angle at all, then you will end up in r theta component. So if phi is not present at all, if you ignore all the phi, then you will have r theta, which is nothing but again what 2D polar. So sphere can be converted to 2D polar if phi becomes 0. Similarly, cylindrical can be converted into 2D polar if z becomes 0. Yeah? So anyway, so the first term remains same. Now additional term that we have here, it is minus, I will just use color maybe for contrast, which is given by minus r sine square theta into phi dot. Okay? And if you have by hearted these things, it's a good time to check your by hearting skills. Okay, r that's the first term. The second term, again the first term shouldn't change, people. R theta double dot plus 2 r dot theta dot, we know this already. This should exist, but there will be an addition. The addition is minus r sine theta cos theta phi dot square. Okay, into we have a theta. Okay, okay. Next, and the third term, complete term, it will be your azimuthal component, the phi term, which is given by 2r dot sine theta phi dot plus 2r cos theta into theta dot into phi dot plus r sine theta. Have any of you by hearted these things? Phi cap.
Cylindrical velocity of spherical. That's it.
I mean, yes, exactly. Like by heart, and what I will suggest you also, just by heart velocity. If at all there is a question on acceleration, then also I will tell you what they will ask max. They'll probably ask you just radial component or tangential component. So maybe you'll have to probably derive things respectively. That's what I mean. Just if I had this now, how much time will it take for you to derive this? 2 minutes maximum if you are in good confidence. You can invest 2 minutes. If it's a question for 2 marks, you can invest 2 minutes any day. Okay. So you can always derive this by heart velocity, those tests also to by heart acceleration. Okay. So again, I'm not sure if I've written all the terms correctly, but okay. So let's proceed.
Sir, previous slide just a minute.
Sure. Okay.
Okay, sir.
And we have a 2 r dot sine theta phi dot, 2 r cos theta theta dot phi dot, and r sine theta phi double dot. Okay, sure. So let's take a question on this now. Here we go. Question number 3. Okay. So we have got a particle moves with phi equals to constant, theta dot equals to omega is constant, and r equals to r0 e raised to beta t is transverse component of acceleration is. First, you have to identify the system. Is it 2D, 3D, and if it's 2D, then which? If it's 3D, then which? So we have got phi, we have got theta, and we have got r. So we have got r theta phi. So obviously, it's spherical coordinate system. And in spherical coordinate, they're asking us transverse component of acceleration. It means they're asking us a theta. Okay. Now, a theta is given by, we remember the first 2 terms, I think so very easily, which is r theta double dot plus 2 r dot theta. Yes, additionally, we have got an extra term, and that term was, what is the extra term here? Minus r sine theta cos theta phi dot square. People, we've got minus r sine theta cos theta, r sine theta cos theta phi dot square. This is an additional term, but okay. The best part right now is they have mentioned that phi is constant, phi dot becomes 0. So anyway, we are not supposed to by heart remember that any lucky. Okay, so phi becomes phi is constant, so phi dot, because phi dot is what derivative of phi, and derivative of a constant would be 0 b. Phi is constant, so this term becomes 0. Next, theta dot is constant. If theta dot is constant, it means derivative of theta double dot will also be 0. It means this term also becomes 0. So what are we left with? Just 2 r dot theta dot. Okay, r dot we can calculate. What is r? R0 e raised to beta t. So r is given to us. R0 e raised to beta t. Let's calculate derivative of r dot. R0 is constant. Derivative of e raised to x is e raised to x. But what is derivative of beta t? Beta. You will differentiate beta t people. B into derivative of t, that will be 1. B into 1, that is beta. So we have got r0 beta e raised to beta t. Okay. So we have got 2. What is r dot people? E raised to, sorry, r dot is r naught beta e raised to beta t. And what is theta dot? Theta dot is omega. So which is our option? Option A. Copy these. That's the answer. So it's not difficult. And listen, even if this question would have been for 1 mark or 3 marks. I understand you may not remember this formula. You remember velocity. Take 2 minutes, derive acceleration patiently. After derivation, once you have this formula, how much time did it take to get this result? Hardly 1 minute. So in 3 minutes, you are getting the result now. It's fine. Every question will require only 3 minutes, you know that. On an average. 180 minutes, 60 questions. Okay. So don't stress yourself to hard acceleration. If at all they plan to ask a question on this, it has to be something like this. On spherical, it has to be something. Okay. Good.
Yes, sir.
Okay. Please ask me if you have any other questions. Next, okay. Proceeding ahead. So I think these were the only questions that I wanted to take on the first chapter, but let me see what is the fourth question. Fourth is now related to Newton's law. So the first velocity 2D, 3D, this is what is expected from us. Usually they will ask you expressions or they will ask you equation of path or something like that. Mostly the questions will revolve around that. Mostly it will be related to 2D polar, nice 2D polar questions. And if at all it will be 3D question, then it cannot be something very humongous people. And yes, this can also create a good question on this related in MSQ section, where they're asking you the derivatives. If you remember r cap, theta cap, phi cap, those are unit vectors, but these are not constant unit vectors. So you are supposed to derive them. And just recalling a few things related to that, people in 2D polar, do you remember r cap is replaced with what in complex number?
E to the
E
by theta.
E raised to I theta, okay? And theta cap is replaced by
iota e squared.
yes, iota into e raised to I theta. Basically, people, if this is point P, if this is an initial line, what is it? Suppose, and this is an initial line. Okay. Suppose somewhere here you have point P. Okay. Then this is your direction of r cap. What is the direction of theta cap? It's always tangential, and tangent is always perpendicular to radius. So, for example, this is a theta, like from here to here. This is a theta. So this creates a circle actually. So you're supposed to draw tangent. This is the direction of theta cap. Theta is always perpendicular to r. Okay. So actually, what happens here, if you remember, is this thing. Wait. So direction of theta cap can be found. It is the same direction, e raised to I theta only, just that you have to add additional 90 degrees. Because if r is like this, then theta is 90 degrees ahead of you. So you have to add 90 degrees. You have to add pi by 2. You have to add pi by 2 to theta. Then you get theta cap actually. Correct now? If this is x and if this is y, so y is 90 degrees ahead. So if this is r, if this is theta, theta is 90 degrees ahead. So you add 90 degrees to it. And then what you do further, you split it. E raised to I theta, e raised to I pi by 2. And here you apply the Euler's formula. What was the Euler's formula, people? E raised to I theta is cos theta plus I sin theta. So e raised to I pi by 2. This is cos pi by 2 plus I sin pi by 2. Okay. So e raised to I pi by 2, that becomes basically cos pi by 2 is 0, sin pi by 2 is 1. You are just left with I. So e raised to I pi by 2 is just I. E raised to I pi by 2 is just I. So you get I e raised to I theta. So this is theta cap. And what maximum we can also ask is, what is derivative of r cap? What is derivative of theta cap? Because the derivative of these unit vectors, it's not 0. Their derivative exists. Derivative of I cap is 0, g cap is 0, k cap is 0, but their derivatives are not 0. Make a note. And ask me if you have any questions.
Time derivative, na?
Time derivative, absolutely. Chalo, next. Okay. And also another important formula of unit vector was this, like any unit vector in the world, let's say p cap, it is given by the partial derivative of r vector with respect to the corresponding variable upon the magnitude of the numerator. And this is what you are supposed to use to find any other unit vector in spherical coordinates and let's say cylindrical coordinates. For example, if you talk about, let's say, cylindrical, okay, and suppose they are asking you that what is the expression of phi cap dot, derivative of phi cap dot. Obviously, you have not by heart this thing, but you can calculate phi cap. How can I calculate phi cap? You need to recall r vector. What is r vector in cylindrical people? It's rho into rho cap plus z into z cap. First thing, okay. Let me make it a bit simpler at the moment. Suppose I'm asking you, let's say, rho cap dot, maybe anything, but whatever. So the point is, suppose r vector is given to you, rho into rho cap plus z into z cap. First, you can find r cap. How can I find r cap? Derivative of, sorry, not r cap, rho cap. We can find rho cap. How can I find rho cap? It is derivative of r cap upon partial derivative with respect to what? Rho b. If you want to find phi cap, then phi. If you want to find z cap, then z. Whatever is the term you want to find, that term you have to use, and then magnitude of the numerator. So take derivative of this, substitute it here, and calculate. We did this whole derivation thing in the class. So once you have
Yes,
rho cap, then you differentiate it, and then you will get rho cap dot. Similarly, once you have z cap, then you will differentiate it, and then you will get z cap dot. Okay? But we have done this whole thing as a derivation only in the class. But the point is, this formula will be very significant because you are not by heart those derivatives. But what if they ask you those derivatives in an MCQ? Then this is how you will find it. Go through the derivation once. Just go through it. Don't by heart it. Just go through the procedure so that if a question is asked, you know what to do after that. And people, sure. Now let's start with Newton's law. Is there anything else first of all you want to cover in this chapter? Do you have any questions apparently related to this chapter you can ask me now? The first chapter, velocity of 2D free coordinates. Any questions you want to ask? Any confusion you have? Clear. Sure. Next, please give me Newton's law. Well, there is no theory in this. In this chapter, there is probably just problem solving and problem solving. I mean, theory, whatever theory he had, we covered those fundamental stuff. You know, like first law of motion, second law of motion, third law of motion. The only important concept that you need to remember is related to the Newton's second law. Theoretical. I'm just speaking theoretically right now. That is rate of change of momentum. The thing is, you need to remember that force is mass into acceleration. This is not always valid. This is not always valid. You know, recently there was a paper that I had conducted and a student had asked me a question. Let me just recall it. Hang on. It was something related to this only, not this exactly, but so the student had found torque using r cross it, but the answer did not match. Can you tell me what would have been wrong? Just asking if you are able to think about it. The student used torque as r cross f, but the answer did not match.
Mass maybe not. Mass maybe not.
No, there is no significance of mass here. No. That is for this thing. What you are speaking about is for NLM. So I'm purposely creating another question on this. Okay. The thing is, people, what is the most fundamental definition of torque?
Rate of change of angular momentum.
Exactly, rate of change of angular momentum. And how do you write angular momentum?
R cross p.
R cross P.
Who told you that r is constant all the time? People, only if r will be constant, then you can go it outside the derivative. Huh? Only then you can write r cross. R cross f is not always valid. R cross f is not always valid. This is something we have not discussed, but I remember discussing this with the student when this paper was conducted. Okay. So make a note, r cross f is not always valid. Only when r is constant, you can go it outside. Because if it is not constant, then what will happen, people? Then you will also have dr vector by dt cross p vector. You will also have first constant derivative of second, and second constant derivative of first. You apply the rule, right? So r cross f vector, and then you have an additional term. What is dr vector by dt? That's a v vector cross p vector. Okay. Make a note. Okay, next. So very similarly here also, people, when you write forces rate of change of momentum with respect to time, this is always valid. You cannot say forces mass into acceleration, this is always valid. We cannot say that this is always valid. Why? Because when you write this d by dt of momentum, this is actually mass into velocity. Only if mass is constant, you throw derivative outside. Otherwise, obviously, there is another option, v vector dm by dt, and this additional thing is known as thrust force. So this is the only important theory in the chapter. Otherwise, it's mostly about problem solving, draw, free body diagram, and solve. And yes, inflation, this is the only important theory. Okay. Ask me if you have any questions, please. We'll just take problems otherwise. Okay. Some random problems related to the chapter. Next. Okay, I hope you're copying this. Proceeding ahead. Let's take question number 4. Sorry. Okay, so this one is a simple question. A pendulum is suspended from the roof of a tree and reaching up 3 degrees with the vertical, find the acceleration of the tree. Actually, they shouldn't have given this additional information, but okay. So basically, this is a pendulum. Right now, this is in some box. Let's say box is a train. Okay. See, I couldn't find time to draw this with a scale, so I have just drawn it with my own hands. I have personally typed this question for you all, okay, so that we save time in the class. I don't have to write this question in the class. But okay, a pendulum is suspended from the roof of a train and makes an angle 3 degrees. Find the acceleration of the train. So first of all, logically, they are not given the direction of acceleration. You have to first guess the acceleration direction. Obviously, it has to be on the right side now. Only then there will be a jerk on the left side. It's only logical. The pendulum will tilt on the left. Only the acceleration is on the right. Just like, you know, bike goes up and you go back. So first you have to guess the acceleration direction. It has to be on the right side. That's first thing. Next, and now you know what to do. Free body diagram and type stuff. Okay. So we have got mg. We have got tension T. We have got acceleration. I've already told you people will always choose x-axis as the direction of acceleration and perpendicular to x-axis as the y-axis. Perpendicular to acceleration as the y-axis. And all the forces must be along these two axes. So mg is already along negative y. I don't have to resolve T. But the problem is with tension T. T is neither along x nor along y. So we have to resolve T into components. Mg will not resolve because mg is already along y. Actually, listen, I'm speaking fast. I know that you have to tell me if you want me to go slow. Okay? I repeat. Next. So tension is already equal at an angle, and we can divide it into components. We have to divide it into components because we want forces along x-axis and y-axis. So let's divide two components. First of all, what about angle? Here you have 3 degrees now. So this will also be 3 degrees. That angle. Huh? So this will be 3 degrees. So this will be t cos 3, and this will be t sin 3. That's it. So is mass oscillating up and down? No, mass is not oscillating. Mass is an equilibrium. It has created an angle and now it is stable. That's it. Okay. So total upward is total downward, I can say. So t cos 3 is equal to total downward, which is mg. Because there is no oscillation up and down, upward has to be balanced by downward. Next, however, you are observing from outside. Remember, you are attached to Earth. you're seeing that the train is moving in the forward direction. So there is mass into acceleration on the right side. However, it is not oscillating up and down, and hence you say upwards is downwards. But you are seeing that the train is going on the right side. So mass into acceleration. Who is the force on the right side? There is only one force on the right side, and that is t sine t. That is t sine t. Divide them. Let's divide. So t sine t upon t cos t. This is equal to ma upon mg. Ma upon mg. I just divided them appropriately. T sine upon t cos. That is ma upon mg. Just divided them appropriately. So t gets cancelled. Sine upon cos. That is tan t. This is a by g, and a is g tan t. A is g tan t. People, when theta is very small. When theta is very small. But remember, there is a mistake which students may do.
Cos theta.
Cos theta, what cos theta?
tan theta theta होगा सर.
Sir,
tan
cos
theta
theta
cos
small
theta
मतलब
को
one है ना?
हाँ,
Sin theta में theta, cos theta में one.
That's what I'm saying. But okay, let me add that. So obviously you know that sin theta is written as theta. Obviously you know that tan theta is written as theta. Yes, and cos theta is written as 1. I was saying a common mistake a student will temptingly do is if I will give you theta is 1 radian. People, 1 radian is not small angle. 1 radian is a large angle. 1 degree is a small angle. 5 radian मतलब कितना होता है? 180.
180.
5 radian मतलब कितना? People, 3.14 radian. If 3.14 is 180 degrees, then 1 radian would be around 60 degrees. 1
Yes,
radian, okay?
sir.
1 radian is not a small angle. Write it in note. 1 degree is small, 2 degrees small, 5 degrees small, 10 degrees small. 1 radian is how much? 1 radian is 180 upon 5 degrees, people, which is around 60 degrees. 1 radian is not a small angle. A common mistake which again students can do, okay? But anyway, so they have given us degrees, so that's a good thing. So g tan t, I can write this g into 3 degrees, but don't write 3 here because this again can happen. You might just end up writing 3g as the answer. People, answers must be in radians. So degrees are not the assignment. 3g is not the answer here. So this is g into 3 into degree. Convert this into radians now, which is pi by 1. Okay, so 3 ones are 360s are, and then you have got you can add GS 10 maybe. So 10 pi by 60. So this is around pi by 6, approximately 0.5. Nearest answer to 0.5 D. That should be the answer. Copy, please ask me if you have any questions. Okay, sure. Next, let's take another question. I hope you have copied it now. You can tell me if you're writing. So here's one. A block A is able to slide on a frictionless incline of an angle theta and length L, kept inside an elevator which is going up with uniform velocity. Find the time taken by the block to slide down the length of incline if released from rest. Okay, so they have given us a block is able to slide on the frictionless surface and the length is L. This length of this surface is given to us, and that is L. Okay, good. Find the time taken by the block to slide down the length. Actually, a word should be written complete length because diagram is not accurate. So slide down the complete length. So initially the block must be at the edge, people. So in order to slide down the complete length, they're asking us the time taken. So we know the formula S is ut plus half at square. Correct. What is the distance traveled? L. L is the distance traveled. Initial velocity, that was 0. Okay. We want to find time, right? So plus half at square. So we have got L is half at square. We have got 12 upon a. This is t square. So we have got t which is under root of 12 by a. Now the question is, we want to find acceleration. Remember, acceleration is not gravity because you're not falling vertically. You are sliding down. So component of gravity is active. Gravity is not active. So we have to resolve it. So listen, let's do one thing. We can throw our, if you remember, our crow inside, or maybe whatever, our shirt guy inside the lift. Okay. We'll take pseudo force as a problem here. Since system is going upwards, people, since system is going upwards, there has to be a pseudo force downwards. But the thing is, they have mentioned it is moving with uniform velocity. Have they mentioned acceleration?
No.
No, sir.
When they say velocity is uniform, it means acceleration is 0.
0.
Okay, acceleration is 0. So there is no any additional acceleration right now. However, for your understanding, you can write that there is a pseudo force which is mass into acceleration in the downward direction. Pseudo always acts in the opposite direction, but pseudo force is 0 item. Okay. So what do we have? We have got this block. It has got mg in the downward direction. It has got a pseudo force which is also 0 actually, which is also 0. Okay. And normal reaction is like this. Acceleration is happening in this direction. So we want forces in this direction. So let's find the forces around this direction. Let's resolve them now. Fp is not supposed to be resolved. Fp is anyway 0. Okay. So we just have mg people. So mg can be resolved into 2 components. One component and second component. Now take care of the angle. Listen, I repeat. Never by heart some of the popular quantities. For example, you have by heart this thing. You've seen this in most of the problems, like A is g tan theta. So it's a very popular formula. A is g tan. It happens in most of the problems. But the thing is, it can also become g cot theta if I shift the theta people to the apex side. For example, here I have given you theta. I can give the same problem when I have written theta here. Then, for example, if we do this question in the class, if in the mock test that you will be giving, same question is asked. Do not be in a rush to mark the answer. Just see whether the angle is also correctly drawn or not. What if I draw the angle here? Then tan will become cos, sin will become cos. Take care of the few things. Huh? So anyway, so this is theta. Here, something like this. And here I have got theta. So people, this will be also theta. We know this now. Okay. So this becomes mg cos theta. Okay. And this becomes mg sin theta. So normal reaction is balanced by mg cos theta. Okay. And mass into acceleration is provided by whom? Mass into acceleration is provided by mg sin theta. So acceleration is g sin theta. Remember, it could be g cos theta if theta was interchanged. Okay. That's it. So our answer is ready. Time taken is how much? Under root of 12 upon acceleration, which is g sin theta. Answer is option. Huh? Okay, sorry, all of them. Okay, so when I wrote this, copy this please. So when I typed these questions, I copied A in option B. I was supposed to make one of them as G plus A, one of them as G minus A, but I did not do any of that. Okay, make a note. Ask me if you have any questions, please.
मैंने ऑप्शन देखा तो none of these होगा आंसर.
Okay. By the way, if same question I would ask, and if acceleration was given to you, then what will be the possible change in the answer?
Sir, G plus हो जाए.
Okay, G will become G plus A. Okay. Because obviously when we go up, people feel heavy now. So the net effective gravity increases. So effective gravity increases, G becomes G plus A. And another way to understand that is there is Ft now. Ft is ma actually. If acceleration would exist, then Ft is ma. So basically the net force in the downward direction is m into G plus A. Okay. So m into mg plus ma. Net force in the downward direction, Ft can common, it's m into G plus A. So now you have to create component of this H. So here you will have m into G plus A sin theta. Okay. And here you will have m into G plus A cos theta. Okay. So m into G plus A sin theta is m. Okay. Now m into G plus A sin theta is actually m. Okay. So mm gets cancelled, acceleration becomes what? Acceleration becomes g plus a sin theta this side. Or you can simply understand that the effective gravity increases, it becomes g plus a. That's it. Okay. Have you copied this? Writing, let me know, first page, second page. Have any created on this? Chalo, next. Let's take another question. So much of energy is required in these lectures also, but okay, greater than the usual lectures. 5 we just did, question 6. So question 6 I have taken especially for one theorem, which is that theorem.
Lami's theorem.
Yes. Okay, so let's do this, people. If the mechanical system shown below is in the static equilibrium, whenever things are in equilibrium, and whenever you have three component forces, you don't have to solve the physics of it. We have learned Lami's theorem, people. It's not an exclusive part in JAM syllabus. It's not there in JAM, but we learned it so that our life could become easy. Okay? And this problem is on a problem. They're asking to find the value of tension T. So it's only time pass. Just look at this area. Okay, you don't have to even look at the other side. This is tension T. Here you have got M. Okay, so here you have got mg. Okay, and here whatever is the value, we don't care what is the value. Call it T2 if you want. Okay, so they have given us this is 45 now. Again, what is this total angle? 135. 90 plus 45 now. 135 people. Again, what is this angle? This is 90. So what will be this angle again? This will be also 135. Right? Sum of all should be 360 now. So 135 plus 90, 135 plus 90 plus this remaining angle, that should be 360. So this remaining angle, if you calculate, you will again get 135. Okay, so this will be again 135. And now you know your favorite Lami's theorem. So how do we say? It's basically the side, I mean the force T2 upon sine of angle in front of it. What is angle in front of it? 90. Please tell me if you want me to guess in any part of this. I'm assuming you remember this. Okay? So T2 upon sine 90. Similarly, T, this is T upon angle in front of T. What is angle in front of T equal 135? So T upon sine 135. Okay? This is mg. This is mg. What is angle in front of mg? Again, angle in front of mg is 135. So mg upon sine 135. That's it. This is Lami's theorem. Force upon sine of alpha plus 4 is equal to force upon sine of alpha is equal to force upon sine of alpha. Alpha is the angle basically in front of it, respectively. So that's it. They're asking you to find the relation between T and mg. Sine 135, sine 135.
Yes, sir. Yeah.
T is mg. Time pass. Okay, make a note, please. This was asked by the way, IIC 2011 paper. I stole it from that. IIC used to conduct its own question papers before 2012 or 13. Any questions? Anyone? Next. Let's proceed. Okay. Here we go. Number 7. Okay, let's do this. Find the reading in the spring balance. This is again a question just to recall the acceleration concept. The little additional concept that I had taught you, the pulley concept and everything. Okay. And
yes, I was about to ask you that.
Okay.
The assumptions.
The assumptions, yes. So assumptions, obviously, it's not. I'm not written here because I wanted to explain it in the class. I thought it's like not typed. So what were the assumptions people in order to solve a question like this? Number 1, the pulley should be massless. What is the reason, people? Do you remember?
Moment of
So that is the moment of inertia is zero.
Exactly. If it is massless, moment of inertia would be 0 basically, and there won't be any angular motion. We can ignore it completely, and a lot of things can be, removed from this idea. Okay, so there won't be any torque 2 further. There won't be any torque because torque is actually I alpha. Torque is I alpha. Torque is I alpha. So if moment of inertia is 0, there is no torque. There is no rotation. If there is no rotation, it will not affect your sliding. Okay, that's one of the reasons that the pulley should be massless. Next, it should be also frictionless. Because obviously our rope should be able to slide very freely on it, and there is no opposition of it. And the rope that we have, the rope should also be massless. Why?
Otherwise, tension is added.
Tension is constant, so
exactly. So that tension remains constant. Otherwise, people tension at each and every point will change. If rope will have mass, then here whatever will be the tension, you will have to add the rope mass. Here you will have this much rope, you have to add this much rope mass. So as you go above, tension will increase, people, because the weight below will decrease. Weight below will increase. So as you go above, the tension will increase. Here you will have maximum tension because you will have that much amount of rope mass that will be added to it. So tension must be constant because of which rope should be massless. And then there are another words that use. It should be twistless, it should be elastic, etc. So it should be rigid, not elastic. It should be rigid and everything. But okay, next. So now let's just recall this. As far as people, the rope is continuous. As far as the rope is continuous, tension is constant. So here we have tension T1, here we have tension T1. It is always towards the point of suspension. This is the point of suspension. Yes. Okay. Now here tension will not be T1 because there is a breakage. As soon as there is a breakage, tension will change. Here the tension will now become T2. So we have got different tensions. Now we have to solve first these three body diagrams separately. Now how will the system accelerate? We have got 2 and 4 and we have got 2, so it has to accelerate in the downward direction here. Okay, we have got heavier mass 6 kg, and here I have got lighter mass, so this will be pulled upward with acceleration. Obviously, acceleration will be same now because the amount of distance that this is going to cover in some time, same distance this will also cover in the same time. So acceleration will be same on left and right side. So let's draw three body diagrams of individual and solve this. Let's start with 4 kg. So 4 kg has its mass into gravity or weight in the downward direction. T2 is in the upward direction. Acceleration is in the downward direction. So mass into acceleration is the force in the direction of acceleration is positive. The force in the opposite direction is negative. Equation number 1. Okay. Now let's talk about second 2 kg mass. You can always tell me if you want to explain it. So weight 2g in the downward direction. Tension T1 in the upward direction. System is accelerating in the downward direction of an acceleration K. Should there be anything else?
Yes, there is a 4 kg mass that has attached. So
Yes.
it's the tension in each area.
Absolutely. So 4 is also going to pull 2 people. Remember, 2 kg is going to be pulled by 4 kg mass 2. It's actually something like this. Here you have a 2 kg, here you have a tension. So it is going to feel the tension here now. So 2 is going to be pulled downwards with the same tension, people, the tension that 4 kg is experiencing. Okay, it is going to be pulled down with the same tension, T1. Because 2 is connected to 4. T2, sorry. 2 is connected to 4. Here you have a T2 now, here you have a T2, and this is 4g. Have a look at the diagram. This is 4g, here you have a T2, and 2 kg is going to be pulled downwards with the same tension. It is going to be pulled downwards with the same tension. So here you have an additional T2. That's important to realize. Additional T2. Many students write 4g here, and that's why they get it wrong. It's not the weight, people, that will be important. It's the tension that will be important. 2 kg is pulled downwards not by the weight of 4g. It is pulled downwards by the rope, by this point of the rope, which is going to pull it with the tension. That point of the rope is pulling it down. It's not because what if there is no rope? There is no rope, there is no weight. No? There is no force. So it's the point of the rope which is experiencing the weight that is going to pull it downwards. So T2 is going to pull it downwards, not 4g. Take care of that. But so let's write mass into acceleration, 2 into acceleration. It is the force in the direction of acceleration is 2g, another force in the direction of acceleration is T2, another force in the opposite direction is minus T1. Okay, that's equation number 2. Let's talk about the third one. So we have another 2 kg mass. We have a 2g in the downward direction. We have a T1 in the upward direction. Acceleration this time is upwards. For this 2 kg, acceleration is upwards. So mass into acceleration, this is force in the direction of acceleration is T1, force in the opposite direction is minus 2. What do you do after this, people? usually.
And
सेकंड में पुट करके T2 निकालना
नहीं, just add all of them. Always, whenever you have 2, 3, 4, 5 cases, just a second, there is a question. So please repeat, my pulley should be massless. See, pulley, if the pulleys are massless, then what will happen? Moment of inertia will be 0, because what is moment of inertia of a pulley? Pulley is a disc. Disc is mr square by 2. So if mass is not there, inertia is not there. If inertia is not there, will there be torque? Torque will not be there. If torque is not there, simple. You can say there is no angular motion of the disc. If there is no angular motion of the disc, it will not carry the rope. The rope will not slide away. Otherwise, what will happen? If you are moving on a plank, the plank will also move. Sliding can happen. So you don't want additional effects. That is why the pulley should be massless. Clear? Okay. So where was I? No problem. So just add all the equations equal. 4a plus 2a plus 2a, which is 6a. This is equal to minus t2 plus t2 gets cancelled, minus t1 plus t1 gets cancelled. That is why the best trick always is add all the equations that you derive using Newton's law, using free body concept. Okay, you're left with 4g plus 2g, which is 6g, 6g minus 2g, which is again 4g. You're left with 4g. Acceleration is 2g by 3. We got acceleration. What next? Now we can find tension also. So let's find tension, people. We can find t1 from here. T1, 2a is t1 minus 2g. 2a is t1 minus 2g. So 2 into 2g by 3 plus 2g. That's 1 minus 2g on left side. This is t1. So 4g by 3 plus 2g. This is t1. So 4g, 3 to the 80 होगा फिर. हाँ yes 4 5.
Yes, sir.
Absolutely yes. ऐसी mistake don't commit in the exam, people. Yes. I have told you since before that I am prone to errors, but you are not supposed to do mistakes like this. Okay.
Because we are watching, so we are aware of that.
But yes, by solving by happiness and out of it, it can always happen. But yes, take care. Yeah. Okay. Next. So 8a. This is equals to 4g 2e 2g gets cancelled. This is 4g. Okay. So acceleration is g by 2. Done. Next. So we have a t1. Let's use equation 3. 2a is t1 minus 2g. Okay. So 2a is what is it? A is g by 2. A is g by 2. This is t1 minus 2g. 2 gets cancelled. So g plus 2g, which is 3g. T1 is 3g. Good. Let's find t2 also. Where is t2? We can use any relation. Let's use this. 4a is 4g minus t2. 4a is 4g minus t2. So 4 into g by 2. This is 4g minus t2. So 2g is 4g minus t2. So t2 is 4g minus 2g. So t2 is 2g. Okay. So I have a t1 is 3g, t2 is 2g. But what is it that they're asking? They're asking us to find the reading in the spring balance, people. This is where I had taught you an additional concept. It's not usually done in the books, people. That is the pulley concept. Pulley is fixed. Pulley is not accelerating. The pulley is fixed. So there is no acceleration. Acceleration is zero. It means total upwards is total downwards. Pulley is experiencing a tension T1. At this point, I'll use a color. At this point, it is experiencing a tension T1 in the downward direction. Here also, it is experiencing a tension T1 in the downward direction. Okay. And then there is a net tension in the upward direction here. Here, the net tension T. Okay, let's call it T net. Whatever. So the total upwards has to be total downwards because there is no net acceleration of the pulley. So T net is 2 T1, T1 plus T1. So this is 2 into what is T1 T2. T1 is 3G. 3G. T1 is 3G. So 2 into 3G. So that's 6G. Okay, that's T net. Now, this I have a spring balance people. This tension T is connected to a spring. This tension T is connected to a spring. The spring will also experience the same tension. Same tension, same concept that we use here. Okay, the same tension that 2 kg was experiencing because of 4. The same tension similarly here. This what you say this spring balance will experience because of this T net. So what will be the reading in the spring balance? It will be 6G. That's it. But remember 6G. This when you say 6G, this is in newtons, and the units that they have used in the options that is only in mass people. So obviously, what is the mass value of this? You can write this mg now. Mass is how much? 6 people. So 6 kg is the option. I hope you understood this. Tell me now.
Yes sir. बस एक ही चीज पूछनी थी ये T2 आपने इंक्लूड क्यों नहीं करा मतलब एक टेंशन T2
No,
तो है
T1 की कैलकुलेशन में T2 is already included ना.
ओके ओके सर
T2 की हमें जरूरत है
हाँ मतलब exactly we did not require T2 right now, but now for an example like here I directly found T1. Finding T2 was not required at all. But without T2 equation we couldn't have solved. We needed this equation to solve because first we had to find acceleration. So equation was required, but finding T2 was not at all important. Something was asking.
So what about 9/4?
9/4? What 9/4?
So acceleration of lift.
Arey baap
There
re.
figure.
Okay, no, I did not consider that at all. Okay, so yes, that is also there, no? Okay, so it's
so there's a pseudo force also
there is a pseudo force also acting on this. Okay, wow. Okay, and you know what is the best part now? We got an answer without the equation that is there in the option. Outstanding. Okay.
yeah I would have just picked mark that
Absolutely.
came back
Absolutely. Okay, so let's resolve this. Okay. Okay, I'll just go to the I'll just redraw the question. Let me retake the question 7. Okay, nice. So good observation. Let's try to solve this now. So the thing is, now that we have a g by 4, there will be an additional pseudo force acting on each of the objects. Now the calculations will massively change. And this is very impressive. I think I'm not sure from which book did I take this question. Maybe I directly took this from an HC Verma. Maybe as far as I remember, in one of the unsolved problems. But okay, very interesting because I'm impressed with this option. 6 kg was there. Okay, so let's do this. So what do we have? Let's start with 2. Let's start with this 2 kg. I have got, let's start with 4 kg first of all. So I've got 4g in the downward direction, and now there will be a pseudo force to people. Okay, what will be the pseudo force? Mass into acceleration. Okay, what is
So
mass?
9/4 in SI.
It's not 9 by g by 4.
Oh, G by 4.
G by 4, G by 4. So this is pseudo force which is mass into acceleration, which is 4 into g by 4. Okay, and now there is a T2 here. There is a T2 here, and system is also accelerating. Very nice. Huh? Okay, so what do we have? Mass into acceleration, which is 4 into acceleration. This is sum of all the forces. The force in the direction of acceleration. 4g plus. Hang on. What is this? This is mass into gravity. Now, people tell me if you have any questions. First, this is rate 4g. And now this is pseudo force, which is mass into acceleration, which is 4 into g by 4. Okay, so 4 gets cancelled. I'm just left with g. Okay, and in the opposite, I have a T2. So 4a is 5g minus t2. This is our first equation. Please tell me if you have any questions. Don't hesitate. All good. Next, let's talk about 2 kg. Nice. Okay, so we have got 2g in the downward direction. Then we have a pseudo force mass into acceleration. It is 2 into what is acceleration? G by 4. And then there is T2 also because 2 will experience a tension due to this. There will be a tension also. T2 also in the downward direction. So many downward forces. This is such a good question. Okay, and we have a T1 in the upward direction, and we have an acceleration in the downward direction. Okay. Good. Please tell me if you have any questions. Don't hesitate. So mass into acceleration is given by T2 plus 2g plus g by 2 minus T1. So 2a is given by T2 plus 2 to the 4, 4 plus 1, that is 5, 5g by 2 minus T1. Okay, so that's next equation. Copy this much. I will go to the next page. Probably you guys are also solving by yourself. Let me have a question here. Okay, next let's talk about this thing here. System is going acceleration in the downward direction, here it is going in the upwards. Okay, so that 2 kg, it has an acceleration in the upward direction, weight 2g in the downward direction, pseudo force, mass into acceleration. What is acceleration? G by 4 in the downward direction, and then there is tension T1 in the upward direction. So mass into acceleration is given by, okay, T1 minus 2g minus g by 2. So 2a is T1 minus 5g by 2. Right. Okay. Let's add people all the equations. So what do we have again? 4a plus 2a plus 2a, which is 8a. Again, all the tensions should get cancelled. Minus T1 is cancelling plus T1, plus T2 is cancelling minus T2. What are we left with? 5g plus 5g by 2 minus 5g by 2. So 5g by 2 minus 5g by 2 is also cancelling each other. We are just left with 5g. So acceleration is 5g by 8 people. This is acceleration. And now we already know we don't need to calculate T1. So we don't have to calculate T2. We can directly calculate T1. So let's just calculate T1 because that's what we require. So what is acceleration? 5g by 8. This is T1 minus 5g by 2. So I've got 5g by 4 plus 5g by 2. This is T1. So T1 is 15g by 4 people. Okay, T1 is 15g by 4. And what was our spring balance? 2T1. So final answer. Spring balance was 2T1. So 2 into 15g by 4. 2 into 15g by 4, which is 30 by 4, which is 7.5g. So our answer mass reading should be 7.5 kg. This is not there in the option. Have I done any?
Yes, sir. मैं भी वही सोच रहा हूँ, मुझे भी same ही answer
Same answer. So okay. Then our answer is very good. It has to be. I must have done something why I may have added from my end. So,
Excuse me, sir.
हाँ,
Sir, इसमें हमारी जो स्प्रिंग की इक्वेशन है वो 2T1 minus kx is equal to mg by 4 होनी चाहिए थी ना?
No. The thing is, again, when we use spring balance or whatever, so
स्प्रिंग की वजह से रिस्टोरिंग फोर्स लगेगा.
the system, I mean, this pulley will be in equilibrium already. If the pulley is already in equilibrium, so whatever is the tension felt, that will be same as kx. That's what now. Tension and kx will be equal, and that will be the reading that will be mentioned here. What happens is when the spring will be pulled in the downward direction, whatever is the spring, that will stretch accordingly, and whatever is the pointer that is attached to that, to that spring, because it will be stretched, the pointer will also read accordingly. Okay, so tension itself, the 2d1 itself is going to give you the reading, because the spring will be in equilibrium. It is not going to accelerate up and down. So kx will be equal to 2d1 itself, and system will be adjusted such that your answer, as they have mentioned, it will be in terms of mass. So don't worry about that. Okay. But okay, our answer is 7.5. Should I just confirm this? Then just give me a minute.
Yes, sir. Please confirm it.
Okay, no, it's not from SCV. It's from some probably random problem that I took from internet. I also searched for problems on Newton's law, and I think I took screenshot and typed it probably. But okay, we'll confirm it eventually. I mean, related to the answer, this concept is not wrong. Concept is absolutely correct. Answer is will be 2T1, and whatever is the answer, that should be the answer. But why the answer is not matching? Maybe it has to be some typo error or whatever. But okay, interesting. Okay, so I'll just check this out later and we'll tell you guys more about it. But our answer 7.5 kg as of now. Keep that in the box. Okay. So let's proceed. Do you have any questions, people, until here?
No, sir. It's perfect.
Okay. Let's the mouse. Okay, got it. Sure. So which was this question number now? 7. Let's take question number 8. Here we go. Okay. So we have got another question. Figure shows a wedge of mass 2 kg resting on a frictionless floor. A block of mass 1 kg is kept on the wedge, and the wedge is given an acceleration of 5 meters per second square towards the right. Then it's an MST by the way. Okay. So one or more options could be correct. However, I have taken this question purposely because to also tell you one thing related to MST. But first, let's solve this. So they have given us a figure, a wedge, a mass, and it's on a frictionless floor right now. I don't think we're having time to cover friction today. I've taken too many problems, but okay, it's good only. A block of mass 1 kg is kept on the wedge, and the wedge is given an acceleration of 5 meters per second square towards right. Because we have shown this on the right with an acceleration of 5 meters per second square. The question is, the block will remain. What will happen to the block? Whether first of all it will remain stationary or not? That's the question. Whether it will remain stationary or whether it will have an acceleration. Okay. So again, what is the concept that I should apply in order to solve this question?
Pseudo force.
Pseudo force. So let's immediately throw our friend Sharakandi people on this. He's going to observe this block, people. Just observe this block. Okay. So immediately, because the system is accelerating in the forward direction, there has to be mass into acceleration, pseudo force in the backward direction. So this mass is 1 kg. This mass is 1 kg. So 1 into acceleration in the backward direction. Okay. There will be a normal reaction. There is a weight 1 into gravity. There is a weight 1 into gravity. Okay. And there is a tendency of motion in this direction. This is the tendency of motion. So I'm going to choose this as x-axis and this will be my y-axis. So all my forces must be along x and y. Okay. So 1g is neither along x nor along y. 1a is also neither along x nor along y. But normal reaction is already along y. So we have to resolve 1g and we have to resolve 1a. So why do I feel we have done a very similar problem in the class, but just not with the values?
Yes, sir.
Yes,
So we
sir.
can have the result of this also. And we have also calculated normal reaction, net force, everything, just not the values. Okay, people, let's not do this right now. That's what I feel. I'll just tell you the answer of this. Very little problem you have taken in the class. You can tell me, but if you want me to do this in class right now. Anybody?
just एक बार ये just
Equations
क्या है?
बना दो. Okay,
हाँ
sure.
बस.
Okay. So firstly, so we have understood that we have resolved the forces. Important is don't choose this as x-axis. That's a common mistake that you may do, and that will give you complicated equations. We will always choose x-axis as the direction of acceleration, but of what acceleration of what you do. Acceleration of the object you are observing. You are observing this now. This has a tendency to go in the downward direction. So this has to be our x-axis, and the perpendicular to that should be y. So let's resolve things. So I have got 1g, I have got 1a, and I have got normal reaction. And this is my x-axis, and this is my y-axis. Normal reaction, it will go untouched because it is parallel to y already. Let's talk about 1g people. Let's resolve 1g into components. So this will be y component, and this will be x component. Y and x, right? This is 1g people, y component, x component. Now listen, this is 37. Okay, so this will also be 37. We know this, like the whole property we have done in number of times. If this is theta, then this is also theta. Okay, so this is also 37. So this is 1g cos 37, and this is 1g sin 37. Okay, normal reaction you are not going to touch, but acceleration can be resolved in two components. Let's resolve acceleration. One component, second component. Okay. Now listen, what about the angles? People, this is 37. Again, this will be 37.
Yes, sir.
Right? The whole same story. If this is theta, this is 90 minus theta, this is theta, this is 90 minus theta, this is theta. So 37, 90 minus 37, 37, 90 minus 37, 37. You just keep on repeating the chain. Okay. So this is again 37. Okay. So this becomes 1/8 cos 37, and this becomes 1/8 sin 37. We have resolved all the forces. That's it. Now, first of all, is the block oscillating like this? No, it's stable. It means total upward must be total downward along y-axis. So normal reaction will be equal to, just a second, where did I write 1/8? So you can always tell if I've written it at wrong place. This is 1/8 cos 37, and this will be 1/8 sin 37. Now it's fine. Okay, this is 1, so 1/8 cos and 1/8 sin. Okay, so normal reaction is balanced by what? It is balanced by these two forces, blue and green. Blue one I have by mistake cut it over there, but these are the two forces that you have. It is balanced by 1 is sin 37 plus 1g cos 37. By the way, 37s are very popular value. I've told you that many times. Sin 37 is 3/5. Correct? No.
Yes sir.
3/5, which is sin 30 is greater than 0.2. Sin 30 is 0.5, and this is greater than.
और cos 37 होता है 4/5.
Yes, cos 37 will be 4/5. Okay, so we have got 3a plus 4g by 5. Okay. Next, again. We don't know whether the system is accelerating or not. So this is the tendency of acceleration. So we are predicting there will be acceleration, mass into acceleration, 1 into acceleration. It is given by 1g sin 37 minus 1a cos 37. 1g sin 37 minus 1a cos 37. Okay. So we have our acceleration, which is g sin 37 minus a cos 37. Or I can say acceleration is. By the way, there will be a small problem. This acceleration you have to write something else. Let's write a dash. This is a different acceleration. No? A dash. This acceleration is a different acceleration. It's not this acceleration. No? It's not 5 people. So write it a dash, please. Here also in the diagram. If I'm not wrong. Okay. So a dash is this. So this will be g sin 37. That is 3/5. Minus a cos 37, which is 4/5. So a dash is 3g minus 4a by 5. We need another equation because we have got three unknowns right now. We have got normal reaction is an unknown. We have got acceleration is an unknown. We have got a dash is an unknown. We need another equation. So whom we can look at? Let's look at the wedge people. Let's look at the wedge. First, if you want to think of this.
Sir?
Hello.
So I got answer of previous question. It's 15.
Okay,
It's 15.
so did we do some error in calculation?
No, sir. The last one, kx is equal to mg by 4. Then sorry, 2t1 is equal to mg by 4. Then we get to 15. Mass is equal to 15.
2t1 is mg by 4. That's fine, but that's what we did now. But I'm not sure. So maybe we would have done. I'm not sure. We probably would have done some calculation error also at some place. So okay, do check this, people. I mean, if the answer is see, somebody's got 15 here. So others also you can see if you're getting 15. Maybe we could have done some calculation error here and there. Okay, it's highly likely because we did it in the rush. So okay. So where were we? A dash is 3g minus 4a by 5. Now let's talk about another equation. Let's talk about wedge B. So wedge is moved in the forward direction, like this. It has mass m. It has got mg in the normal direction. What is mass of wedge? It's 2 kg now. Okay, so mass is 2, so this is 2g. Wedge will have its own normal direction n2 people. Okay, what else is missing on this?
The other mass is also feel its weight now.
Yes, so there will be a normal reaction exerted by the other mass people in this direction. Normal reaction is perpendicular to the surface. So there will be n1 also. Okay, so here we have got n1. Okay, now we will choose this as x-axis because this is acceleration direction and this is y-axis people this time. Okay, so you don't have to resolve n2, you don't have to resolve mg, but yes, you have to resolve n1 people. You have to resolve n1 into components. So let's do that. Okay, I've got n2, I have got mg, and now let's resolve n1. So n1 is here. I have to resolve it into components. Wait, n1 is here. Let's resolve n1 into components. So this is n1, and okay, this is vertical component, this is horizontal component, this is vertical. What about theta people?
37.
Hi, 37. Okay, so this is 37. So this is 37, right? Okay, so this one is 37. Okay, hello. See, this was 37 people. So this one will be 37. 37, 90 minus 37, 37. You just keep on creating the chain. Okay, so this is 37. So this one will be n1 cos 37, and this one will be n1 sin 37. Okay, good. So and where is acceleration? Wait. Also, the thing is,
don't you have to include pseudo force?
no, the point is because the guy is observing this, so we are not considering acceleration. We will be applying only pseudo force in the backward direction. Okay, so here we have to write n. No acceleration. So just write n like this. Instead of acceleration, who is our observer? Observer is sitting here now. Observer is sitting here, people. So when you are on the platform, you don't know whether the platform is moving or not. Okay, so all that you can apply is pseudo force in the backward direction. That's it. You don't know the acceleration of your train. Okay, so hang on, because where is this right? Because the wedge is going in the forward direction, there will be a pseudo force on the wedge in the backward direction, which is ma. So what do we have? Just a second.
Net left hand force. It seems like that.
No, something is still missing out. There has to be a force given to us. Block of mass and is given an acceleration. I think given an acceleration. It's moving in the forward direction. That's fine. We have got mg, we have got n, we have got a. What now? Until here things are fine. This is n1 sin 37, and they have given an acceleration. Why should we include pseudo? But then if we don't include pseudo, this doesn't make sense. because there is no force on the right side. There should be a force on the right side. But okay, wait. Figure shows a wedge resting on frictionless floor. A block of mass m is kept on the wedge. Is given an acceleration of 5 towards right. When you see it's given an acceleration of towards right, what is the meaning of that? That there should be some tension. Like I think we had taken this kind of equation. I remember now. There was a string, it was connected to a pulley, and there was a tension T. And the tension T was pulling the wedge right now. Somebody should pull the wedge right. Only then it can move on the right side. Otherwise, how can it move on the right side? There has to be a force on the right side. Don't you think? How can it move on the right side? We have taken this problem in the class. Do you remember?
Yes sir. हाँ पर पूरी था ऑब्जर्वर पुल कर रहा था उसे.
हाँ, basically there was I think a wedge here, a mass, and the mass was pulling it, something like
Yes,
that.
उसके weight के हिसाब से.
Right. But the thing is, if they have mentioned that a block is given an acceleration of 5 towards right, so somebody has to apply that. Okay, so maybe I can change x and y axis in this if I want to apply pseudo, but then I cannot consider mass. Forces we have included. There is acceleration. If I don't want to include acceleration, then I have to apply ma here. And if I apply ma here, then somebody must balance it. And if I want somebody to balance this ma, I don't know why should somebody balance it, but something should be there. No? In that case, we'll have to. What is mentioned in this? Let me check this question. Again, I'm not sure if it is there in this book or if I just taken it from some places. Okay, this is an HCV question only, but it's an unsolved one, so we'll have to check the solved book of this. That's only in PDF format. Sad, but let's try some another approach on this. Just thinking. Okay, this is m, this is 2. We have got 2g in the normal direction. We have got normal n2. Okay, and we have a normal direction n1. These are so different. I mean, nothing is changing here, and there is an acceleration. If I want to apply, okay, wait, hang on. So there is normal, like this, a normal, not normal, not normal acceleration. Don't we have any other force? Okay. Okay, I think if you are applying a force, and since there is a pseudo force of 1a on left side on the block, should have be 1a on the right side too. No. Acceleration is in the forward direction, that's fine. 5 meters per second square that they have given us, 5. Okay, and we have resolved everything mostly here only. I just want to add one thing in this. Like I'm trying out. I'm thinking we might need to add 1a in the forward direction, but will that help? 2a would be 1a plus n1 sine 37 in that case. Sorry, 1a minus. No, I'm getting negative. 2a is 1a minus. Doesn't work. Trying your books to people. Let's get this done. 2a. We have. Okay, what if I don't change the x's of symmetry that you already had? This was x and this was y. What if we keep this as it is? The initial chosen x and y. Okay. In that case, suppose if I apply pseudo force like 2a, let's try that idea. So in that case, I don't know acceleration. I'm just going to keep it a. Okay. So what now? Let's try this last method. If this works, then it's good. Otherwise, we'll just take it later. I've understood what is the last attempt that I'm trying here. So the last thing I'm going to try for now is I'm shifting the coordinates table. I'm using the original xy axis that I chosen for the first block. Let's try to keep that xy and resolve forces along that and see if we are getting some. And if we are doing that, in that case, you will apply pseudo force because this was the coordinate system chosen as per the observer. Okay. So because you apply a pseudo force on the block, there has to be pseudo force on the wedge too at the same time. The whole system is moving in the forward direction. So there will be a pseudo force on the backward direction too now. Let's try this last time. Okay. So now I want forces along. We have got how many forces? 1, 2, 3, 4. 4 forces, and I want all the forces along y and x. Okay. So y is here, okay, and x is here. So n1 is not supposed to be resolved. We don't have to resolve n1. N1 will keep as it is, but we have to resolve all the other factors. So let's start with n2. N2 is here, N2 is here. What about the angles? Here I had 37, if you remember. So this becomes 90 minus 37, and this becomes 37. Wait, 37, 90 minus 37, 37, 90 minus 37, 37. Okay, so this is n2 cos 37. This is n1 sin 37. Last step. Okay, let's try this. And tell me if you have any questions in this idea right now. Otherwise, later it will get confusing. Should I re-explain what I'm trying here?
No, sir.
All would you say no? I did not consider. Okay, if somebody needs an explanation, let me know. So n2 cos 37, n1 sin 37, and then let's resolve this 2a2. So we have got 2a cos 37 and 2a sin 37. N1 is not supposed to be touched, and 2g we have to resolve. We have got 2g. Just a minute. 1, 2, 3. Okay, N1. 2g cos 37, and this is going to be 2g sin 37. Okay. Now let's talk about x-axis and y-axis. Since you have applied pseudo force, total up should be total down and total right should be total left. There is no acceleration right now. You don't know because you are inside the tree. Okay. So total up n2 cos 37 is total down. 2a sin 37, 2g cos 37. 2a sin 37, 2g cos 37. Okay. And total left is total right. Okay, now we are getting something. And okay, good. Phew. Okay. So n1 sin 37 plus 2a cos 37, we are getting something. I hope this is only logical and we get to this. This is equal to total right, which is 2g sin 37. Okay. What after this? what after this? Now that's the question. Huh? So we have got n to n1 relationship again, and here also we had what are the relationship that we already have. We have got n. This is n1 by the way. The original n is n1 now. The original n is n1. So we already have n1 relationship. So I think we can derive another n1 relationship from. Okay, let's write this neatly. So we have got n2 cos 37, which is 4 by 5. This is equal to 2a sin 37, which is 2a sin 37, which is 3 by 5. Okay. Then 2g cos 37, which is 4 by 5. Good. Next, and what's the other equation? n1 sin 37. So n1 sin 37, that is 3 by 5. Sorry, no, 3 by 5. Then 2a cos 37. So that's 2a 4 by 5. This is 2g sin 37. So 2g into 3 by 5. You can tell me by any chance I've written anything mathematically wrong. Physically, I think you have done it correctly. And we can substitute the value of n1 from the original equation. What is n1 equal? n1 is 3a plus 4g by 5. You can substitute this. n1 is, and we'll get acceleration. 3a plus 4g by 5. I shall tell you the answer of this because I don't have the solution, but I have the answer here of SCD. So before we solve, okay, this is the first question. You know, where now. So it's written, but I'm not sure. Answer is probably just option C. Just option C. It's MSQ, but at the end of it, like I said, I wanted to tell you all that in MSQ also you can have MCQs, people. In fact, because one or more options can be correct. So one can also be correct, but two or more can also be correct. That's the idea. And I think in last year or last year's paper, out of 10 MSQs, 3 were actually kind of MCQs. Only one was only correct. Okay. But okay. So let's complete this. 3a plus 4g by 5. This is 3 by 5 plus 8a by 5. This is 6g by 5. So multiply all of them by 5 and you get rid of 5. So we have open the brackets. 9a plus 12g. This is plus 8a. This is 6g. So we have got everything is in plus. 9a plus 8a, which is okay. We are getting negative now.
5 is missing, sir.
5 is missing from where?
Sir, 3a plus 4g upon 5.
3 plus 4g. That's okay. There is a multiplication now. Yes. Okay. So there is 5. Okay. So we have got 9a plus 12g plus 5 into 8. That's 48. This is 6, 5. This is 30g. Are we getting something now? 49a. This is 18g. So a is 18g upon 49. By any chance, if the calculation is correct. So anyway, we got an acceleration. We are getting something. Calculation could be hilarious also. Acceleration so far is this. What we can check is this. So any option A and option B, that is not matching. That's good indirectly. Normal relation, let's find. Normal relation of the block. Are we getting 11 or not? Let's just see. If not, then we can again just check the calculations later. Normal relation, just find n1 people. Where can we substitute this? Here. 3a plus 4g by 5. Okay. n1 is 3a plus 4g by 5. 3a plus 4g by 5. By any chance, if we get the result, then it's good. Okay. I will just confirm the calculations here. 3 into 3, that's 9. 4 into 3, that's 12. 8a and 6g. And then 5, 5, 5 cancelled. And then 5. So if I have 40, 30, which is 18g and 49. Okay. So we have got 3 by 5 acceleration, which is 18g by 49. 49, okay, plus 4g by 5. Nothing can cancel, no? And we are not even close to 11. Are we close to 11 meters per second square? Check the final answer. So not meter, 11 Newton visible. So 18 3s are 54. And 49 5s are 245 plus 4g by 5. This will be 0.8 plus. Okay, it seems like we are getting a result. Okay, 54 divided by 245. That's 0.22 people plus 0.8. That's 1.02 into g. Unless until calculation has got wrong. So 1.02 into 9.8. Maybe it's around 9.996, approximately 10 or whatever. Okay, so we are getting around 10. Maybe some calculation somewhere here and there should be hilariously wrong. But okay, our answer, correct answer is 11 Newton actually.
Sir, 12.11.
You got 12.11?
Yes, sir.
I'm getting something else on the other end. But okay, just check. The process is same. I will also maybe try this once more and get a ready-made solution and just will show you it tomorrow. Okay. So we'll stop here, people. Thank you so much. We'll continue with friction and central force and everything tomorrow. You and me.
Thank you, sir.
No
Thank you.
problem. No problem.
Thank you, sir.
No problem.